So we're going to do a talk on web security, on how to not get hacked. So a lot of the examples in this talk will be node based, but the principles apply to everything. Some of the security exploits that we go through can happen no matter what environment you're running in, language and framework. So the examples will be in there, but you can easily apply them to any other system you're running in. So I'm Scott Smith, and I'm a software developer at Degreed. Degreed's a education startup that's biggest mission is to jailbreak the degree. Pretty cool mission, worth checking out if you're into education and learning, which I think all of you are since you're here to learn stuff. So check them out. So starting off, how many of you have heard of OWASP? Some? Cool. So it's the Open Web Application Security Project, and their biggest mission is to really stay on top of security issues on the web. They release a top 10 security list every year or two, and it's a really good list to look at and read through to understand what security vulnerabilities are out there. And they also provide a lot of information of how the attacks happen, how to protect yourself. A lot of good information to go off. So this talk is going to go over about 5 of those top 10s, more of the ones that are applicable and a little bit more easy to discuss from a code perspective. And so the first one is injection. And injection is it's not a new vulnerability. It's a very old one. I'm sure a lot of you have heard of SQL injection attacks. And essentially what happens with injection is it's all about the attacker sending text-based attacks in order to exploit the syntax of a targeted interpreter. So that can be SQL. It could be like SQL Server or MySQL or Postgres. It can also be directly at node, actual like a script-based attack. It can be MongoDB. It could be really anything out there that's interpreting text to do something with that text. So some of the ones for SQL injection, like you've got SQL Server, Postgres, MySQL. So here's an example Express node application. And the part here that's important is to kind of look at where it's, within we're posting to a /login endpoint. And within there, we're basically pulling out a username and a password to then look up that user within the database to see if they exist. And what's happening here is we're basically concatenating and building up this SQL string here using the username and password as user input. And the reason that's really bad is if someone was to do a post to that endpoint using a username like this, where you have a user equals quote space or 1 equals 1 dash dash, which looks a little funky. What's happening here is the data being passed in is taking advantage of the SQL interpreter, and you can end up with a SQL statement that looks like this. So you have a select all from users where user equals empty quote or 1 equals 1 dash dash. And what happens is the dash dash is actually a comment in SQL. So this SQL statement will actually end up matching all users within the system and pull out all users. And I mean, it could be further expanded where if you knew someone's username, it could be where the user equals quote, admin, or somebody you're trying to exploit. But a lot of times this works really well because in a lot of systems, the first user in there tends to be someone that works for the company and has admin rights. So it really doesn't matter what the username is. By doing this, the person will gain access to the system. So the first way to combat this is to always escape user input for SQL statements. And a lot of libraries out there have that functionality built in. In this example, it's more pseudocode. I have this connection module here, and it's calling escape on the input from the users. But whatever module you're using for communicating with your database, be it MySQL or MongoDB or SQL Server, Postgres, escaping the user input it's always really important. And something you'll gain from this talk is pretty much to never trust user input. User input is bad. You should just treat it as bad, and that bad things can happen with it. If you go from that viewpoint, you'll kind of by default harden your application. And so by doing this bit of code, what happens is that previous exploit, the actual SQL statement will look like this instead. And so what happens is it says, we're going to query for all users where the user is equal to pretty much everything within those quotes, the or 1 equals 1 and the password equals whatever, which isn't a valid user in our system. And so this, just by changing an escaping user input, can stop this type of attack. The other way in which you can do that is using parameterized SQL queries. And so the way you do that is, in this example, is in the statement here, you see we're not building any type of like string for the SQL statement. Instead, we're using parameters, the $1 and $2, and then using an actual query method on our database object. And within that SQL statement, supplying the input, the username and password, as parameters to that call. So it's more of a replacement. And in doing so, you'll end up with a safe SQL statement as well. All right, so SQL is not the only way in which injection can happen. You can have injection within Node directly, where people can actually inject JavaScript into your Node application and have any JavaScript they want arbitrarily executed, which is also very bad. And the way in which that can be done is if you do use eval within your application, you're setting yourself up for failure. So eval of any type of user input it's very dangerous. As in this example, say you have some endpoint /run where you want to run a command. So maybe it's an admin function that you left exposed, and someone's able to post data to it, and the command cmd is the script you want to run. If someone were to post to that, say with command equals while one console.log hacked, you're going to basically end up just causing an infinite loop there, just outputting to the console, the text hacked over and over again, which is not good. I mean, this is a really simple example, but if you have that in place, they can run anything they want within your application. So the simple way to solve that is just never use eval with any user input, and use it with care when you're using it for other reasons, because it does definitely open up a hole within your application. So another one is MongoDB. It's obviously a NoSQL database, so you don't have SQL statements, but there are ways in which people can exploit it as well through injection. And this is one I actually had when I was putting together this talk. I found in one of my applications that I had this hole within my app, so changed that immediately. And it's not as clear and obvious at first. So the main line here that's important is the db.users.find within the login method. And we're saying we want to find a user where the user is equal to the username passed in and the password, which looks okay. It's just going to find a username and password. But the problem here, and it's not not clear, is that we're not explicitly setting our query selectors. And so the query selector is something like the $GT and $GT for username and password. So if a hacker wanted to get into this, they could post the user parameter as that JSON object. And what ends up happening is you'll get db.users.find where the user is greater than empty string and the password is greater than empty string. And pretty much every user in your system is going to have a username and a password that are not empty. So you're going to pull out all users. So it ends up being a similar attack to the SQL injection as well. So the way to combat that is to always use explicit query selectors when you're using MongoDB. So instead of letting them pass in greater than and specifying the query selector, in this case we're using $in for the username and password. And what that's saying is to find a user where the inputted field of username is within that field. And so when someone tries to submit the previous attack, you end up with something that looks like this, where you're saying find me a user where in that field is that object of greater than : empty string, which isn't going to be found. It's not a valid user, and so it'll stop those kind of attacks. So just a rule of thumb, always be aware of query selectors within MongoDB. Okay, so that was injection. The next type of attack that's very prevalent and you need to be aware of is we have broken authentication and session management. And this is where you're not handling session IDs correctly. You're not protecting username and passwords very well. Things of that nature. So we'll go through some examples. The first scenario here is somehow the attacker gains access to your database, and you're not properly storing your passwords. You're basically storing passwords in plain text. And people actually still do this. There's a lot of sites that still do this, unfortunately. You would think that by now people would not do that, but they do. And obviously that's just a really easy attack. You get a hold of that database, you've got all the usernames and passwords. Not only do you get it for that system, but a lot of times people use passwords over and over again. And so now they've gained access to that user's account all over the place. So a really simple solution is to, and you should always do this, is hash passwords. You don't want to encrypt passwords, and you don't want to store them in plain text. And the reason is you never want a way to figure out what that password is. You want a one-way transform. You want to take that password, store it in a way that if someone gets that hash, it's really, really, really hard for them to undo that. And you can't really necessarily undo a hash. There's things through rainbow tables where people can figure out what it is by doing hashing and doing matching. But it definitely makes it much more secure. And to do that in Node, there's a bcrypt package you can use. And essentially what I've got here are two functions, a hash password and a verified password. And so the hash password, when the password comes in, it generates a salt and then goes ahead and hashes that password. So the password is now in a one-way transform. You store that hash password in the database along with the username. And then when someone logs in, you take the password they submitted along with a hash and then do a comparison to verify that that's valid. So you look up the user, pull out the hash, take the password they gave, run it through a compare function using bcrypt, and you'll know whether or not it's the same password. But in doing so, you're not actually storing the password in plain text. So if you ever have a site where you forget your password and you say, I forgot my password, and your password comes back to you in an email, you may want to close that account. Let them know it's not cool. Or unique passwords all over as well. Exactly. All right. Second scenario for sessions and authentication is site will end up supporting session IDs within the URL. So an example here is bank.com/account !session ID equals 1, 2, 3, 4, 5, 6. So that session ID identifies you as well as your current session. And if someone gets a hold of that session ID, technically they can impersonate you, and they can make requests, and the end site thinks it's you. Obviously, that's very bad. And having it within the URL is even worse because things like sharing of links. Say you accidentally share your link to your friend. Hey, check out this cool link. Well, your session ID is in there. They now hit that, and they've actually logged in as you, and you can do anything they want as you. It can get stored on cache servers. It's stored in browser history. It can be leaked through the referrer header. So if you click out to another site, the referrer header will have that previous URL and can have that session ID in there, so another site can see that information. It can be leaked through logs that aren't properly stored or protected. And just in general, it's much more visible and dangerous. So you really want to protect session IDs. They're very critical to having high security just because of the amount of access that they provide. So solution one is to store session IDs in a cookie and never in the URL. And a lot of sites do this now. I mean, I think it's fewer and fewer where you see them in the URL. And it's really simple to do that in an Express application. You can use the Express-session module, and then just add it in as middleware to your application. So the app.use session, and then you generate a secret. You want a nice, secure secret there, so that way someone can't essentially decrypt the cookie information. And then another scenario. So say you've got, you're hashing your passwords, and you've got session IDs stored in the cookie. Is where a site employs long or no session timeouts. And the reason that's bad is if for some reason someone does get your session ID, it can be really hard to ever revoke that session ID. And that session ID can be good forever, essentially. Even if you log out yourself, log back in, it doesn't matter. If that information is stored within that session ID, they still have access to your account. This is one that you have to work out yourself very in detail. Do you want short sessions, and what does that do to the user versus long sessions? So it's a usability versus security question that you have to kind of analyze, but it's something to be aware of. And so you can explicitly set expiration for sessions. And in this case here, the second line underneath our secret is a cookie and setting the max age to 2 hours. To me, that's a little annoying, to be logged out after 2 hours. You can do things where you have a sliding window, so as long as you're active, that 2 hours gets reset. But again, that goes back to the problem where if someone has it and just keeps browsing with it, that session stays valid and they have access to your account. So it's not one with a perfect answer. I think it's more one to be very aware of in your applications. The next scenario then is if the user accesses a site, say on public unencrypted Wi-Fi, over HTTP. So you've got like two insecure channels. One, the request to the website is just over HTTP, which is already inherently bad because it's not encrypted, it's all in the clear. And then just being on an unencrypted open Wi-Fi makes it even easier for someone to see that request and get all that information out of there. And if you're doing this, it doesn't matter if you're hashing your passwords. The password's going to get sent in the clear. The session IDs are going to be visible within the cookies. And to do that, we always want to run your site over HTTPS. If you have anything sensitive, anything valuable, you never want to have it running over HTTP. And then another solution to that is to not allow cookies to be sent over HTTP. So there's when you set a cookie, there is a flag you can set on that cookie, which is called secure. And by default, if you don't set that, the secure is, I believe, false, which means the cookie can be transmitted on request to an HTTP endpoint or an HTTPS endpoint. So say you run over HTTPS, but in a lot of cases, you're going to have an HTTP endpoint open because someone may just hit your site by typing in the domain directly, and you want to do a redirect to the secure endpoint. Well, if a hacker knows that and you don't have the secure flag set to true on your cookie, they can make you in some way or another make a request to the site over HTTP, and your browser will send that cookie along with it. Even though the site's going to redirect back to the secure channel, your cookie will have been transmitted in the clear on that one request. So by setting secure:true in this case, you're telling the browser that this cookie can only be sent on a secure channel. So the browser won't send it over an unsecure channel. And I just made a note here, and this is something that bit me running on Azure, and you can hit it on AWS as well, is you can have HTTPS terminators. So when you make a request to say like Windows Azure, it's over HTTPS, but then it forwards your request to your application over HTTP, and it adds some headers to that. And if you don't set this trust proxy to 1 for this particular module, it won't think you're on a secure connection. So if you're running this and you see that it's not allowing the cookie to get set because it doesn't think it's secure, you might be behind a HTTPS terminator or a proxy that's forwarding the request to your application. All right, third solution, and these are not like exclusive. You should be doing all of these things. You know, the more things you do, the more hardened your application is. It's the whole onion effect, right? You layer security after security, so if they get past one thing, something else is there to stop them. And that's to tell the browser to never make requests over HTTP again. So it's a really cool response header you can set. It's the HTTPStrict transport security, or you'll see it referred to as HSTS. And what it is, it's a response header, and it tells the user agent to never make requests to this domain over HTTP for a certain amount of time. And the way you do that is, at least in Node, it's a package called Helmet. But all it does is just sets up a response header that can go back. And in this case, I've set it to say 90 days and include subdomains. So any subdomain for the next 90 days, the browser's been told to never make a request over HTTP. So even if you were to type in http://mysite.com, it will not make a request. It'll go to HTTP. It'll make a secure connection instead, which is really good because then you don't have to worry about someone hitting it and having to do a redirect back and having that potential hole on that initial request. You can also, I don't remember the domain, there's a registration through Chrome where you can register your domain with their HSTS system. And what happens is Chrome, Firefox, and Safari will use that like registration list to know of sites that never want to be requested over HTTP. So even if you don't, it's a way in which you can do it now without doing any code changes on your application. So you could register your domain with that service, and then once that update rolls out, the browsers will just adhere to it. Oh, and this is at the bottom here. That's what the response header looks like. So if you're not using necessarily any packages, if you were to set up a response header with strict-transport-security, you can tell the browser to use that. And a fourth solution is to not let client scripts read your cookies. There's a flag on cookies called HTTP only. It's kind of a weirdly named one. It used to throw me off because I thought it meant more like only send over HTTP, but it's not really what it means. What it does is if HTTP only is set to true, it tells the browser don't let any client-side scripts access the cookie for that domain. So if it's not set to true, client-side scripts can get a hold of your cookie and use that information. If if you have your session ID in there or any other valuable information, you could be compromising your application. So pretty much always set that to true unless there's a reason you have not to. And then again, in this case, it's pretty simple, just HTTP only : true for the cookie. Okay, so that's broken authentication and session management. The next one is cross-site scripting, or XSS. And so what cross-site scripting is it's basically when the attacker takes advantage of the user's trust in websites. So the users trust where they're going. They trust that what they're going to get back is legitimate and not necessarily bad. And because of that, there's ways in which attackers can take advantage of that and cause exploits. So there's two different types. There's non-persistent and there's persistent. The first one, non-persistent. So as an example, we'll go through an example on this to make it clear. There's a site, and on that site, there's a search. I mean, there's a lot of search out there, right? So you can do a search on the site, and the attacker's playing around, and they search on there, and they search for puppies, and then the response page comes back with the results, and they notice that part of the response says, you searched for puppies, here's the results, so what's happening is they're seeing that the site's returning back the input they're putting in, and so playing around a little bit more, they drop in a simple script tag, maybe just throws out an alert, and when they search with that, it hits the result page, and an alert comes up, and they basically know they found an exploit because that server's not escaping or sanitizing that input, and they're just dropping back to the page whatever someone types in. So what happens and how an attacker can take advantage of that in a non-persistent attack is some way or another they get the victim to browse to a page that they control. So maybe they spam out emails, they drop it on social media. It really doesn't matter how, but if you or somebody clicks a link or follows a link to that attacker's site, and it may look legitimate, your browser makes a request to that, in this case, the index.html. What that site returns back is a simple HTML page, but within there it has an anchor tag where it's like click here to go to this site. And in other ways, they could actually make it even simpler, where they could that's correct. It's basically they've got a link on here, and if you click that link, what that's going to do is your browser's now going to make a request back to that site. But the query string, if you look here, it's going to have script, alert hacked script. Obviously, it can be a lot worse in there. It could be a script and include another script that does a lot more stuff. You can do encoding on that data, so it doesn't look like it's kind of hacked. It's just a bunch of random characters that the browser will interpret as script. And so the victim now makes a request to that page with that search, with the query string being the script. And what happens then is the site returns back a response, and in that response has extra script been added to it. So these attacks are all about inserting client-side script into the browser, and doing so with this. Essentially, they've hacked this person, they've hacked the site in a non-persistent way, because it's non-persistent in that it has to happen over and over again. There's not information stored on the server that would continue to happen, but it's more of an active type of an attack. And the next one is a persistent. And it's funny, I wish I'd taken screenshots. I don't know if Drew's in here. When Drew first set up the Develop Denver site for this one, you could put in your bio, and he left it totally open. And I did my little script, alert hacked, and when I viewed my profile, boom, little alert popped right up. But people were doing some fun stuff. We told him about it. He turned it off eventually. It would have been more fun to have had that as an example, but yeah. But for this example, imagine a site where you can post comments, and the attacker finds out when you post a comment, it allows script to be posted as well. It's not sanitizing the input. Similar to the search, but in this case, it's going to be persistent, because when you make that comment, in that comment that gets stored within the database, that script's now in there. So now it's in there always. So no matter, all you have to do at that point is get a victim to browse to that comment. And you may not even have to actively do it. If it's a big site and they're just in there looking at forum posts and they open one up, that comment is going to get loaded within their browser and it's going to contain that script. It's going to get executed and then do whatever whatever they want it to do with that. And again, send valuable data, whatever the hack may be. So these are really bad because then they're just continuous, and at that point you have to clean up your database, remove information to get rid of them. Yeah. Yeah. Uh-huh. It could scrape the page. So say it's bank and you've got account information on that page, account IDs, it could be, social security number if it's shown, yeah, anything. And so essentially these things are all about injecting client-side script into web pages that are viewed by others. So one solution is to escape all user input. Again, it goes back to the theme I was saying is just don't trust user input. You're gonna have problems with it. And this is the exact same situation. There was user input technically for the search, user input for the comment. Even though someone else is taking advantage of that, it's all essentially user input. And so to do that, there's a lot of libraries for sanitizing input, escaping characters. In this case, using the express validator functionality. And on some of my apps, I like to just kind of, as a rule, do this type of middleware, this app.use function. And what I do is just iterate through all of the data being posted and just sanitize it all. So that way I'm making sure anything coming in is going to get sanitized. I'm not doing it case by case because sure enough, I'll add, someone will add something later and forget to do it, and you've just opened up a hole. But you can also do it on the way out, and it's a design decision, and it's something to stay on top of, because it's either when it comes in or goes out. It's going to be when you want to do it, but you don't necessarily want to do it both because you're gonna double sanitize it, and you can end up with invalid data going out to the browser. So in this case, by sanitizing, say they were trying to post, they try to post this script alert, hack script. On the right is what it actually looked like sanitized. It's going to change all of that into ampersand GT, semicolon for a less than, and so that way the data goes out, and then the person's just going to see some junk string within the actual comment itself. Another solution you can use is to tell the browser to allow content from trusted sources only. So there's a kind of like the HTTPS response header, there's a content security policy, which is CSP. And what that is it's another response header that you tell the browser the domains it should consider as valid sources for content. So you can tell it, so what domains are allowed to go out and load scripts? Do you allow inline scripts? Do you allow inline CSS, images, all that kind of stuff? So you can really use the CSP response header to lock down the application. It's only going to work for browsers that actually support it. So newer browsers do, older ones don't. But again, it's just another layer of security you can add to your application. And in this case, again, like the HTTPS, using the helmet package. And what I'm saying here is for default source, self is okay. So the domain itself, it's okay to go and get other scripts from and other content. I'm saying I'm allowing Google Analytics for script. I'm allowing inline for styles, but cases like script, yeah. So inline script itself is not allowed. If you want to have inline scripts, you have to actually specify it, and that's a really important one because a lot of these attacks do kind of inline script within the application, and if you specifically use CSP, those inline scripts won't be allowed to get into the browser and actually executed. It stops that from happening. And this is just what the response header would look like if you were just to do it yourself. Okay. All right, so the next one is cross-site request forgery, or CSRF. And so what CSRF is when the attacker takes advantage of the website's trust in the user. So the previous one is the user's trust in the website. This is where the website actually trusts the user and what they're doing. So the first scenario here is exploiting sites that support changes via GET requests. I know none of you guys are doing that, right? No changes over GETs. Well, sites do that, unfortunately, and it's definitely something to not do because it's really easy to take advantage of. I mean, this would be really bad, obviously, like a bank. But say the user or the victims has already logged into the bank. They've got their session ID, all that kind of stuff set. An attacker gets the user to browse to the site they control. They make a request to this index HTML page. And the response that comes back is an image. And the source of the image, though, is to the bank's endpoint of transfer, question mark, which, transfer to this account, these dollars. And essentially, because the user or the victim is already logged in, and the attacker was able to make their browser make a GET request to the bank in this case with those query string parameters, and they allow change over GET, then the browser will make that request with the session ID. They're logged in, and in that, oops, sorry about that. And in that case, the response comes back, and now the person's lost a bunch of money. I mean, it's a pretty extreme example. I'm sure banks don't do that, but it's a case in point that how easy it is if you do allow changes over GET for an attacker to make changes within your application. So again, solution, don't ever allow changes via GET, only post. Now, scenario 2 here is tricking the user into posting exploited data to sites. So what happens here, again, same situation. The victim's already logged into the bank, and the attacker gets them to browse to a site they control. But in this case, what they return back is a form, and the form does a post to the bank.com/transfer, and it's got 2 hidden fields in there, so the person's never going to see anything when they hit the page. But the very bottom is a script tag, and it does a document.bad, which is the form name there, .submit. So what happens here is technically at this point, the victim's browser is going to go ahead and do a post to the bank with the hidden fields that are named the proper names for those forms. And when it does that post there, the data will get posted, and it'll be accepted because they're logged in, and in this case, they've just transferred money to their own account from that person. All right, so the way in which to solve that is what's called the synchronizer token pattern. And what it is you're setting up 2 things. You're setting up a cookie that goes back in the response headers, a CSRF cookie, and you're also setting up a hidden field in your form data. And what happens is every request to the page that's going to generate one of these tokens that's going to go within the form is kind of generated based off of the cookie itself that gets sent back to the browser. So it's kind of hard to explain, but the request comes in, and when the response goes back, it's going to have a set cookie response header with this CSRF header in there, as well as within the form element, it's going to have a CSRF token. And so that way, whenever someone submits that form, that token has to be there. If that token's not there, it's gonna basically throw an error, and it's not going to allow the post to happen. It's going to help take care of the example I was previously showing, and this is what essentially what the hidden input field could look like. It'll be different depending on what system you're running in, but it's a pretty standard pattern to use, because if we go back and look at this example here, this case they're building this form. It's not going to have that CSRF token in there. They're not going to be able to guess what it is because it's sent back in the cookie, and it's generated, new ones generated every single time. So when this post happens, it's not going to allow it to occur. It's just going to throw an error. All right, and the third scenario, this starts getting pretty far along, but there are ways that people can bypass CSRF protections with clickjacking and HTTP parameter pollution. And so what's going on here is we've got the same situation. They make a request to the attacker site. But what comes back is an iframe, and in that iframe, they're just loading up the bank's transfer form. So the bank's page is getting loaded within an iframe under the control of that attacker. And what happens is it goes and gets that request, returns the response here, and this is where it gets a little, I don't say shady, but there's ways through like clickjacking where they can kind of set up through CSS overlays over that form, that iframe, and little hacks to make it look like you're doing something that you're but you're really not doing. So when the actual user clicks something, they're actually clicking the submit button on that embedded form within that iframe, which has the CSRF token in there. It has all that valid information and would allow a legitimate post to happen. So there's multiple ways to fix this, and in this example, I intentionally left it pretty broken, and because there's lots of ways in which this is happening that can be addressed. So the first thing is to never use query string parameters for data. So if you're posting, technically, if you ever see it, sometimes you can throw in the query string the same parameters as in the post data that's being posted, and it allows it to work. You really don't want to do that, because in this example, because they're embedding that iframe within the attack page. Let me show this here. What happens is when this, on the far right here, the form that comes back, if you notice, it doesn't have an action set up on it, and that's another thing I'll go over. You should always set the action, but because there's no action set, it technically allows them to set up this iframe with query string parameters. And so when someone were to click post or unintentionally click post, when it posts at that endpoint, it will post those fields on the right, but it's also going to post the data within the query string. And so if you're allowing data to get changed based off of the body of the post data or query string, it allows this attack to happen much more easily. So really what you want to do is to not allow data within the query string. So the solution here is, and I kind of said it before, is explicitly set the form action. So instead of leaving it blank, set it to bing.com/transfer, and that basically removes the ability for query strings to get tacked on to that post data. So in this case, you would have posted all these data points, but the actual value would have been empty, because it's the actual form that was loaded from the page, because it's embedded within an iframe. And the next solution is to not use query string parameters for user input. Kind of already talked about that. And then the third solution, which is really good, is to use the Xframes options response header. This is another response header you can set, and it tells the browser to not allow, well, it tells the browser what you want to do with your page when it's loaded within a frame. And the options are allow, deny, or same origin. So what you really usually want to do is set it to either deny or same origin. So if there's cases where you want your page to be embedded within a frame within your own domain, then you would set it to the same origin here. Otherwise, you want to set it to deny. And then what happens now is, in this attack, if they try to embed your page within that iframe, it would not allow it. The browser wouldn't even allow it to happen in the first place. So all three of those things together help to mitigate that kind of extreme clickjacking case that gets around the CSRF tokens. And this is what the response header could look like. So if you're using deny, the first one is what would go back, or same origin. So they're really pretty simple things to do to help just secure your application. Okay, so the last thing is using components with known vulnerabilities. So component vulnerabilities, can cause almost any type of risk imaginable. And the reason is that if you think about it, the components that you're including in your application run with the full privilege of the application. So you're essentially trusting something that someone else wrote in your application that's running with full privileges, on your web server. As in the case, this example's almost a year old here, but there's over 100,000 NPM modules. I'm sure it's much greater than that now. So it's it's hard to know, how do you trust all of those modules? How do you know these modules are secure, that they're written well? There's one security, it's called the Node Security Project, and they've got this seriously ambitious goal, as they even say right here. It's probably too small to read, but our goals are ambitious. Is that they audit every single module in NPM and check for security holes, risks. And the cool thing about that is they have a package. It's called NSP that you can include within. You can either include it globally or within your applications, and you can run it to then verify, are you using any NPM modules that have security risks or security holes in them. So in this case, you can install it globally, and then just run NSP audit package, and it'll scan through any modules within the current directory and see if there's any security risks within them. But you can also install the grunt NSP package, so you can set up as part of your grunt file a task that runs automatically. So every time you build, it can go through and verify that all the modules within your application don't have any known security risks in there. And here's just an example of that output. And another one, and I imagine there's probably stuff like this for for Ruby gems and NuGet packages for .NET and all the others. This one's called David, and what David does is it just monitors your the package you're using to make sure you're on the latest version. So it's just a nice way to know that you're always on the latest version and up to date. So you can install it globally as well, and just run it to verify any applications that are out of date. And actually, and the nice thing is if you look at the bottom, it actually gives you like an npm install command that you can run to then update all of those packages for you automatically. So again, it's something you could build into your automation or your build process to make sure you're always running on the latest packages as well. All right, so those are the top 5 I was going to talk about today. There's 5 more listed here. There's insecure direct object reference, security misconfigurations, sensitive data exposure. You get it. And there's a lot of problems. I'd highly suggest if you are interested in security or want to make sure your apps are secure, is to go to OWASP and look at the top 10 list and go through them. They've got a lot of really good information that explains the attacks, how they work, how to protect against them, that you can then apply to whatever framework that you're running in. So here's some of the npm packages that I referenced. I'll tweet out a link to all these slides after the talk, and some further reading as well. Some good links on cross-site scripting, CSP, a lot of the stuff that we talked about today. So yeah, that's it for the talk. Any questions? Anyone awake? Asleep? Yeah. That is so. What Tabo was asking is it better to do parameterized SQL statements instead of escaping? And that's I've heard that as well. And the reason being is sometimes there have been cases where the escape module there's been a hole found. There's something that doesn't escape properly, and in doing so, opens up a hole. So doing parameterized SQL statements and scripting it's definitely, I think, a more hardened, secure way to do it. Yeah, and it depends. If you're using something that doesn't support that, you may have to stick with escaping and kind of stay on top of it. Anything else? Okay.
The other thing is that if you have like a single page app and you can't do the CSRF thing, then you should absolutely not use cookies. Basically,
yes.
never use cookies. Use a bearer token because they're not automatically submitted requests, right? So if you have a bearer token, you choose when you do.
Yeah. Yeah. And I don't know if people in the back could hear what he's saying is if you're doing single page applications, don't use sessions within cookies. It's really bad. You want to use bearer tokens or maybe JSON web tokens, JWTs, and things like that, because they don't get auto submitted automatically. Any question? They might. I have not come across any, but if you do find some, let me know. I mean, it's always good to have as much coverage as you can. All right, cool. All right, thanks everyone.